All right. Good morning. I think I will start before you guys join me. There is no light here, so my battery is already going down while trying to connect. So, in our previous class, we introduced this course and discussed toxicology, the concept of toxicology as a field of study, and we went back to talk about some historical perspective of how this thing started from the beginning. And then we talk about branches of toxicology down to forensic toxicology, and we clearly mention why forensic toxicology, what are the aims, what are you expected for you as a forensic toxicology or somebody who passed through this course to learn from forensic toxicology. How do you apply forensic toxicology in your specialization? So like I said, we also have gone through some historical perspective of toxicology itself, talked about forensic toxicology, some divisions of forensic toxicology. We extensively discuss about those response relationship. I'm sure by now you must have an idea about toxicity and then other than toxicity. The response of a chemical can have a response or can elicit a response. And that response can be a positive response, can be a negative response. And we classify the positive response as the response needed. For example, when you are dealing with a drug, you take a drug and you're expecting the drug to elicit some certain positive response to cure your own condition. But you have from the negative aspect where that drug, depending on the concentration, can elicit some negative responses which deal with toxicity. They give you some signs or symptoms that you were not expected. And then we talk about pharmacokinetics and pharmacodynamics. We have laid the foundation as a forensic toxicology to you should be able to understand a particular chemicals, how a particular chemical is being uh, or what happened to a particular chemical when it enters the body, and how does the body also how does the body deal with that chemical, and how does the chemical also deal with the body? If the chemical deal with the body, it produces some certain symptoms. So as a forensic toxicology, the first thing you will encounter maybe a situation that has to do with poisoning. Maybe if at all the person is alive, you can be able to observe some certain symptoms, and observing those symptoms, you can easily relate them to some of the common drugs or chemicals that have been used in committing crime, like CNS stimulant, CNS depressant, narcotics, hallucinogen, or inhalant. Or even if the person in question is dead, you can be able to discuss with the people that he lives or the people that saw him before he died, and acts of some of his characters, some of his behaviors. Those behaviors might directly be linked to some of the behaviors that has to do with responses due to the actions of drugs. So you should be able to know what does this chemical do to the body? What responses, what symptoms does this kind of chemicals produce? Or what responses, what behaviors does a person elicit? You can be able to know if that person is actually under the influence of a particular chemical, under the influence of a particular drug. So that is the reason why we have to talk about the pharmacodynamics. And we classify most common drugs that has been used to causes this kind of behaviors, these certain behaviors that can make someone to go and commit certain crimes. We classified them. These are the basic ones. So most of the drugs that has been used to commit crimes, or maybe under the influence of those drugs, you can go out of your sense and go and commit quite a number of crimes, fall under these classes of drugs. So you should be able to at least know what they do, what are CNS stimulants, what are CNS depressants, what they do, what are narcotics, hallucinogens, inhalants. We were able to discuss them, and we talk about extensively how they were able to induce or rather alter certain behaviors in persons that are taking them. we also went ahead to talk about pharmacokinetics. So from the pharmacokinetics perspective, where we discuss the fact that, yeah, these chemicals enter the body. When the chemicals enter the body, what does the body do to those chemicals? We extensively talk about the process of administration, different method of administration, because method of administration determine how long, because sometimes a person can commit a crime or something can happen to somebody, and you as a forensic toxicology, your attention will be brought, you will be allowed to come in, and then somebody will tell you that, oh, this thing just happened a few minutes ago. He was okay. He left just here, and maybe after some discovery analysis, maybe you find out some chemicals in the system, which is beyond or even above the normal dose, or exceeding or reaching a fatal dose, what we call fatal dose. We'll discover what is fatal dose shortly. So you can be able to know, oh, so if at all he behaved normally a few minutes ago and now he behaved somehow, meaning that probably whatever he took or those chemicals he took might have been taken through a route that can easily concentrate or becomes bioavailable within a short period of time. So you should be able to think of the common route that such chemicals can be taken in, and while assessing or doing your assessment, you should be able to identify those different routes, be able to be sure or to confirm or document that this thing was actually taken and it was taken through this route. That is why within a short period of time, he was under the influence of the drug. So we talk about distribution, how these chemicals are distributed to different parts of the body. We talk about metabolism, how they are metabolized. We talk about interactions during metabolism that you can have. Some individuals, two people can take some certain drugs, and at the same time, this individual will exhibit higher influence behavior that has to do with the drug, while another person may elicit a bit lower in terms of the intensity of the behaviors. So all these things happen based on metabolic differences or changes, sometimes interaction. Maybe that person has took another chemical or took another drug before they took that toxic chemicals, or before they took maybe somebody who took paracetamol and then together with aspirin, and then they will take CNS stimulant. Yes, of course, maybe you can have paracetamol being metabolized by a certain enzyme, but that paracetamol at the same time can inhibit an enzyme that metabolize this CNS depressant they've taken. So, of course, if that happens, then you will have the metabolism of that CNS depressant in that individual that took paracetamol to stay a longer period on his system. So staying longer period on his system tells you that the influence of the drug will be for a longer period of time. So you can have that individual that didn't take paracetamol, as in this case, maybe after 2 hours, may get rid of the influence of that CNS depressant, while that individual that took paracetamol, due to the paracetamol inhibiting that enzyme, making the metabolism of that CNS depressant to be very low, will have still an extended influence, or will be under an extended influence of the CNS depressant. So, this is metabolism. Please, if you don't understand the explanation in the previous video, I'm sure with this simple example, you should be able to relate. Yeah, this is what the explanation was all about. So we go back and then carefully listen and understand what was discussed there. And then we talk about excretion, where we say that we have a different organ of excretion, and depending on the chemicals, and it can be through urine, it can be sweating, it can be breathing, it can be through fecal or rectal excreta. So you should be able to, knowing this different type of drugs and knowing this different route at which maybe these things can be excreted, you should also be able to trace that, okay, let's take the urine of this person. If the urine is available, we can check. In fact, if it's a dead person, you can take out the urine, some part of the urine. You can take some sweat. You can take some of the excreta to detect the presence of those things. Most especially some chemicals were best known to be excreted in a certain way. So you should be able to identify that, oh, this is what was taken, and based on the literature, that this thing is mostly excreted through urine. then you can take a urine sample and be able to detect the concentration of that and then establish whether the concentration was actually a fatal dose or not. But in most cases, if a chemical is even a non-chemical that people usually use, for example, if you are dealing with somebody who is a non-drug addict, and you are suspecting that actually he took this drug and that what made him, or that's what killed him, then you should be able to know so many things which we will discuss about some factors affecting the toxicity. And from there, you should be able to have an idea that, yes, an individual who has been used to taking this kind of drugs may be different from an individual who has not been taking them. So in terms of the concentration in the body, even when you carry out some analysis, you discover that, oh, the concentration of these things is higher in this individual. It may actually be higher, but at the same time, it may not be harmful to him. But at the same concentration to somebody who has never been exposed to may be harmful to that individual. So these are some of the things we've discussed in the previous slides. So you should be able to, okay, these are the things we just talked about. And this is the assignment question I told you about. So we'll talk about the assignment question maybe toward the end of today's class. So in today's class, we'll talk about poisons and toxins. Although I have already told you that this part will be an assignment part actually. You will discuss about this in the assignment, but still we will talk about one or two things about poisons and toxins. So that while writing the assignment, you should have an idea of where you're supposed to touch. Anyway, poison and toxins, yeah, they are the same thing. We talk about chemicals, and we know that these chemicals will influence biological function. But we said there are chemicals that influence biological function in a positive way. Mostly they were classified as drugs. But remember, dose response curve or dose response relationship, where we talk about even these drugs can be considered as toxins depending on the concentration. So poisons positively and negatively interfere with the biological functions. That is why they are classified under poisons. Another thing, other reasons that made them to be classified under poisons, that those ones that are clearly different from drugs. They were just poisons because even at lower concentration, they were proven or they have been proven to be toxic, even at a very small concentration. Remember in dose response relationship where we said some chemical can have a positive effect, maybe at lower concentration, but at certain concentration, they can start to exhibit some negative biological responses. And then we said some of those poisons that are most commonly used in committing criminal offenses will actually leave no traces. They don't leave traces. But you as a forensic toxicology, somebody that doesn't have an idea about the pharmacokinetics and pharmacodynamics we talked about, maybe he will say, okay, only the pharmacodynamics, the aspect that has to do with the behaviors that somebody will exhibit to do to those things will be the ones that will determine whether this person is actually under or was intoxicated or was poisoned or something like that. But you as a forensic toxicology, you should have a better knowledge and in-depth knowledge that, oh, apart from those behaviors, there is pharmacokinetics. You can actually trace some metabolite, some chemicals in the body, which are as a result of the exposure to those poisons. You can be able to trust them, and you should be able to correlate the concentration you have gotten from different tissues, depending on the tissue you are expected to check. And you should be able to know that, oh, this concentration discovered is not supposed to be as high as this. Therefore, the death could be as a result of the concentration or poisoning of this and that. So it actually leaves traces, but to somebody who doesn't know, it doesn't look like it. Especially if the person died. The person died, you want to know. And even if he didn't die, somebody will look like, oh, this person is exhibiting some behaviors that has to do with a certain common, well-known natural disease symptoms. So it could be a stroke, or it could be an allergy, or it could be this, it could be that. It could be stomach flu. It could be neurological issues. These are symptoms of some natural disease, but in reality, they are also at the same time symptoms of different type of poisons. But you, as a forensic toxicology, you know poisons, you know different type of poisons. You should be able to know that okay, these patterns, behaviors were actually due to the influence of this and that poison. So you can, from there, you have a rider so that you can be able to check more to carry out some analysis to confirm the presence of those poisons in the targeted organs, or in organs that you feel, oh, this chemical is being excreted through here, or this chemical is being concentrated in the blood. So you check the blood concentration, you check the urine concentration, you check the concentration in the excreta, or you check the concentration in the sweat, etc., etc. So in either case, the symptoms can be rapid and can be slowly. So we talk about poisons and toxins. Somebody will say, oh, why poisons and toxins? They are the same thing. Yeah, of course, they are the same thing. Poison is just a general name, but toxins were only poisons that were produced by living things. Of course, there are those that were not produced by living things, chemically or synthetically produced. We all classified under poisons, but they are called toxins if they are actually produced by a living thing, either it's snake, bacteria, etc., etc. But specifically, those ones that were injected directly into the victim, either by snake bite or insect like scorpion, they are called venom. So this is basically, so the poisoning can be intentional, it can be accidental. And so you as a forensic toxicology, you should also be able to know a cases of accidental poisoning and intentional poisoning, depending, for example, based on the type of poison that was used. You know that, oh, this kind of poison can be accidentally eaten. So it can be food poisoning. That is why sometimes still that has to do with food poisoning is found very difficult to sure that, or was it a natural death, or somebody killed him, or it was just an accidental poison, or it was an intentional poison. So you should be able to know what the person has ate. How did he eat that person? Was it accidental, or is it a common thing that a normal dish he ate? Where did he eat the food? All those things will tell you that this could be accidental or it could be intentional. Maybe the person doesn't eat certain type of food. A friend came and he brought the food to him, or even if he do, but the food wasn't cooked by him. A friend brought the food, and you discover there was poisoning in the food, and maybe both the two, the friend and him, died. Then it could likely be accidental. But if only one person died, maybe the food was brought to him and he ate. The friend didn't eat, and maybe there's poison in the food. All these kind of things you should be able to know and to be able to trace that or where these things are coming from. And that you should also be able to differentiate between what we call idiosyncrasy. We'll talk about idiosyncrasy. There's basically hypersensitivity. So it could be based on the fact that all of them ate the food, but the person that brought the food didn't die, and the person that ate the food really actually died simply because he has this hypersensitivity, or maybe the food contains some certain proteins that are allergic, and it can induce hypersensitivity. And as a result of that, that can lead to the deaths of that individual. So many things as a forensic toxicology, you should be able to differentiate, or you should be able to carry out a proper analysis to tell you that, yes, this thing is accidental poisoning, or this thing is an intentional poison, and it is responsible maybe for the days of this individual. So quickly, poisons were classified into two. We have corrosive poison, we have metabolic poison. Just a simple difference. In corrosive poison, it's just a poison that apart from interfering with the biological functions, it also interferes with the structure of the cells. For example, corrosive poisons are poisons like acid. If somebody pour an acid on your face now, or to your eyes, it won't only affect your ability to see, it will also break and crush those cells of the eye. Is that true? So also, so just think of any poison that apart from disrupting the function, if you drink or take it or somebody for it to you, apart from disrupting the function, maybe on your skin, disrupting the function of the skin, it also break the architecture, disrupt and kill the cells. They are classified as corrosive poison. And I've given you an example of all these strong acid like hydrochloric acid, like sulfuric acid, like nitric acid. Some of them were used in detergent, disinfectant, automobile battery. We all know that. So one thing about them is that they send a warning signal. Most of them send a warning signal. For example, like hydrogen fluoride or phosgenes, that once you are closer to them, you should be able to perceive that, oh, something dangerous is there, especially acid, maybe wherever if you come across acid, like nitric acid or sulfuric acid. Once the bottle was opened and you don't even notice, but you will know that, yeah, something very repulsive is somewhere around you. So this is one thing very common about the corrosive poison. While the metabolic poisons only interfere with the biological function. So you can eat them in food and enjoy the taste, enjoy everything about them. But when they enter the body, then you start having some problem because they express some of those damages to you. And you will only notice that through behavior, some certain behaviors. In most cases, metabolic poisonings were used in committing crime, most especially while killing somebody. Although there are cases where, of course, corrosive poison can be used to kill or can be used to damage somebody, more especially cases of a boyfriend-girlfriend problem where maybe your girlfriend did something to you and, there are cases like that where maybe the guy may decide to say, okay, is it not because of beauty, this skin and this and that you did this to me? And, they can take an acid and decide to damage the cells. So to decide to damage the paste, for example, and that will make somebody to look different. In most cases, these are the most common cases where corrosive poisons were used. But metabolic poisons, they are silent killers. You want to commit a crime, you want to kill somebody silently. Like I told you before, historically, states, countries, rather uses this as an execution. Maybe a court incriminates somebody and then this person need to die based on the judgment. Then the state uses poison, poison that individual in his food and kill him silently without any this. So we have a different type of poison. We have acute poisoning, subacute poisoning, and chronic poisoning. Based on the explanation given earlier, we said in acute poisoning is a type of poisoning where you will have an exposure over a short period of time. An exposure over a short period of time. This exposure can be in high concentration, it can be in low concentration, but the exposure occur within a short period of time, leading to expiration or formation of these symptoms, behaviors that has to do with poisoning. So usually we are talking about the time, for example, 24 hours. Within 24 hours, an individual can be exposed to a particular chemical and that lead to a poisoning. And this type of poisoning, we call it acute poisoning, irrespective of the concentration. In subacute poisoning is when you have up to like weeks, 3 weeks, 4 weeks. Within that range, you have subacute, we call it subacute poisoning. But in chronic poisoning, usually occur over a long period of time, even years. And usually it involves a short concentration. You are exposed to a small concentration of lead today, tomorrow, next tomorrow. Over a long period of time, you are not expressing any type of behaviors or influence. Your behavior wasn't influenced by the lead you've been exposed to, but this chemical will accumulate over a long period of time in your system. And over a long period of time, it can lead a certain concentration that will start influencing some physiological functions in your body. So you start exhibiting some poison, some behaviors, and those behaviors will be as a result of the poison. This type of poisoning, we call it chronic poisoning. So we have also different, it can be suicidal, homicidal, accidental, which I've already started explaining. We know what is suicide, we know what is homicide, can be accidental, I've explained, can be judicial, which I just say that is state execution, it can be abortifacient in the case of cases where abortion is meant is the target, but you ended up killing the individual based on that. So the next thing is I went ahead to highlight some of those metabolic poisons like carbon monoxide, and we made mention that carbon monoxide is a metabolic poison. And one thing we mentioned about most of those metabolic poison, they will have some symptoms that you even think that, oh, these are the common disease you know. For example, confusion, chest pain, nausea, vomiting, headache, dizziness, fatigue, and all these things look like something that has to do with maybe a viral illness, a flu, a stomach. It can be migraine, hypoxia, neurological issue. So maybe easily the doctor will not be able to capture that, oh, this could be poisoning. Actually, it can relate them to some certain disease based on the symptoms that have been expressed. So, how does carbon monoxide causes poisoning? This is the molecular mechanism. Now, what is the molecular mechanism through which carbon monoxide causes poisoning? Now, we know that in our body, what does blood do? Wow, my battery is going down. So please, I'll be a bit more faster. My battery is going down. Are you with me, please? Okay.
Yes, sir.
Okay. So my battery is going down, so I'll be a bit faster. Regarding the carbon monoxide poisoning, the poisoning occur as a result of the fact that normally oxygen binds to hemoglobin in red blood cells. And we know red blood cells involved in transportation of oxygen, right? To different different part of the body. So hemoglobin will carry oxygen to be called oxyhemoglobin and transport it to different tissue. And then the tissue will use the oxygen to carry out what we call electron transport chain, which is cellular respiration, which is the process of energy production in the body. And once the energy is produced, the cell can utilize them for their activities. So also this same hemoglobin, after releasing oxygen, it will carry carbon dioxide, the carbon dioxide that was released at the end of cellular respiration, and it will be taken back to the lungs, and from the lung, it will be exhaled out of the body. So if you are exposed to a place where there is carbon monoxide, and we know carbon monoxide is produced usually during incomplete combustion of whatever, of chemicals or of wood or whatever, incomplete. Instead of producing carbon dioxide, produce carbon monoxide. So carbon monoxide tend to be more denser than oxygen. So if you are in a room and there is oxygen, there is carbon monoxide, there is all the tendency that the carbon monoxide will replace the oxygen in the room. So the oxygen will go and you can likely inhale the carbon monoxide. So if you inhale the carbon monoxide will bind to hemoglobin to form this carboxy hemoglobin. So this carboxy hemoglobin making the oxygen not available. So the oxygen is not available for cellular respiration. So energy production will not be possible in the body. Then you start having this weakness, confusion, vomiting, and whatever. And that leads to pink complexion of the tissue. So these are just the mechanism of carbon monoxide poisoning. I've already told you what carbon monoxide leads to. And then we have cyanide poisoning, and cyanide poisoning also attack or inhibit the cellular respiration process by inhibiting a particular enzyme we call cytochrome C oxidase. And this prevents the utilization of oxygen. But in this cyanide poisoning, the oxygen is there, but its utilization is being inhibited by what we call cyanide. And the cyanide is a common chemical that is found in pesticide and plastic during electroplating. It can be found in plant, fruit, in certain concentration. So the poisoning also had a number of symptoms that resemble heart attack, stroke, panic attack, sepsis, etc., etc. So we also have heavy metal. We have different heavy metals. So these heavy metals can also elicit this toxicity, and they can cause a number of symptoms like nausea, vomiting, diarrhea, confusion. And you know, of course, if you see diarrhea, it can be flu, it can be chronic fatigue, it can be anxiety, etc., etc. But the reality is it actually a disease condition that has to do with heavy metal poisoning. So as a forensic toxicology, you should be able to know that, okay, once you observe this, it could actually be this. It might not be the flu or just a chronic fatigue or anxiety that many people will think of. Then we have another a chemical, an alkaloid, a beta and colorless that is being used in production of pesticide or rodenticide. Yeah, called strychnine. Strychnine is a neurotoxin. It will interfere with the normal functioning of the nerve cells. So what happens is it blocks the neurotransmitter called glycine. And this glycine is responsible for calming nerves and muscle cells. So without glycine, you will have this action potential continuously being firing uncontrollably due to the fact that glycine was made unavailable, and this leads to muscle spasms. This muscle spasm continuous contraction and relaxations of muscles, and it look like cases of tetanus, epilepsy, hypocalcemia. So not knowing that this is actually due to the intake of this particular poison, and this particular poison has been used in killing quite a number of people, committing a lot of crimes. So we go to factors affecting poisoning. What are those factors that affect poisoning? Please, you have to pardon me because my distance is going down, so I have to be fast. So we have two factors we are classified into two. We have factors that has to do with the poison itself and the factor that has to do with the host individual, the person himself, the condition of the individual that took the poison. So first of all, quantity, we've explained what quantity does response relationship. The higher the dose, the higher the response, the higher the possibility of the showing these responses, unless in some individual where you have the may not be due to the high dose, because sometimes the high dose can actually induce vomiting. So if the high dose induce vomiting, the dose may not actually lead to the high quantity of the poisons you've taken. Like physical form, solid, liquid, and gas. We know gas can easily be absorbed into the body. If you are exposed to this poison, gas can easily be absorbed to the body than solid or than liquid. Therefore, there is high tendency that poison in the gaseous form can easily cause damage because it will reach different part of the body within a short period of time. Likewise, liquid can reach different part of the body higher than solid. Likewise, even the solid, the powder one can reach higher than maybe the one that is granular. Then we have the chemical form. We talked about metallic arsenic and metallic mercury that are less or no poisonous, while some non-metallic arsenic, like arsenic oxide, which is in arsenic arsenic 3, arsenic oxide can be very, very toxic. Like mercury also, metallic mercury may not be poisonous because it may not be easily absorbed into the body and reach the different part of the body and cause the toxicity. But in it, mercury chloride can easily reach the body, a different part of the body, and elicit those problems. So all these things can be some of the reasons why the poison can actually can affect the action of the poison itself. And then we have the route of administration. We talk about the route of the administration, depending on where. We talk about intravenous, we talk about inhalation, sublingual. These are some of the routes that they can easily get to different part of the body, while oral, it may take a longer period of time. We have cumulative action. We talk about some of those poisons that can be taken small, and they will accumulate in the body. When they reach a longer period of time, they will accumulate in high quantity and they can elicit their problem. There could be interaction, systemic or metabolic interaction. We talk about metabolism. where maybe some chemicals can cause antagonistic effect or synergistic effect. I just gave an example with respect to somebody taking CNS depressant while another person taking paracetamol, and I said paracetamol might be an inhibitor of a particular enzyme, and that can lead to a synergistic effect whereby increasing the effect of this CNS depressant due to its ability to stay a longer period of time in the biological system. But it could be inhibition at the same time, a situation whereby maybe the paracetamol increase the activity of this enzyme. Therefore, the CNS depressant you've taken can easily